Good day everyone. In this video, we will discuss taping corrections. We will start off with an introduction and then this will be followed by a series of videos solving problems related to taping corrections. Let's start with the table that you see right here on the screen. We have three columns: the error type, error source, and if the error is systematic or random. Let's start with tape length. This is I, which stands for instrumental, and this is also systematic. Systematic means that we can compensate for this error. So we have a formula that I will be showing you after we discuss this table. So this is instrumental in nature because there are times when your tape is no longer of correct length. So if your tape sustained damage in your previous survey and you tried to mend it or repair it, then chances are it will no longer be of correct length. Let's move on now. Now move on to temperature. So we have N, which stands for natural. So your tape will expand or contract depending on the change in temperature relative to the standard temperature of the tape. Okay, so this is S or R, systematic or random. But the fact that we see an S right here, we can correct for it. And we have pull. This is P, which stands for personal, because the one applying the pull is of course the surveyor. Even if it is personal, this is systematic. We can still apply for it if we measure the force that we applied. And then we also have sag. Sag, this can be natural or personal, and it is also systematic. I will show you the situation for sag when I'll show you the formula later. So we also have alignment and tape knot level. These are both personal, and these two are also systematic. Okay, we can correct for this using the Pythagorean theorem. And we have plumbing, marking, and interpolation. These three are personal, and these three are also random. So in order to prevent these errors, due care in taking the measurement is advised. Let us now move on to the formulas that we'll be using to compensate for the systematic error shown in the table. First is the incorrect tape length. So it is CL is equal to small l minus small l prime over small l prime multiplied by big L. So CL is the correction to be applied, small l is the actual tape length, and then L prime is the nominal tape length, and L is the measured length of line. So don't worry too much about this. I will show you a formula and how to use this. I will show you another video on how to use this. We have temperature. You have correction due to temperature is equal to K times T1 minus T multiplied by L. So of course our CT is the correction to be applied, correction due to temperature. We have K, coefficient of thermal expansion and contraction of the tape. This is given in the problems that you'll be solving. And then T1, temperature at the time of measurement. Okay, and T is the standard temperature of the tape, and then L is the observed length of line. Now we have correction due to pull, CP is equal to P1 minus P times L over AE. Now CP is the correction to be applied, correction due to pull. And we have P1, this is the pull applied at the time of observation. This can be in pounds or in kilograms, so you have to be careful about the units here. And then P is equal to the standard pull for the tape. Okay, we have the cross-sectional area of the tape. This is usually given in the problems that you'll be solving. And then E is the modulus of elasticity of the steel. This is also usually given. And then finally, we have L, the observed length of line. We have sag right here. Okay, so CS is equal to negative W squared times L cubed over 24 pi, P1 squared. So CS, the correction due to sag. And then L is the unsupported length of tape. And then W is the weight of tape per unit length. And then we have pull of the tape measured in pounds or kilograms. So what do you mean by this unsupported length of tape? I will show you. So if you have a line right here, I'm going to try to draw a line. So assuming that is straight. So this is the ideal level of our tape. But due to the weight of the tape, it will tend to sag. So the sag is usually just small, but I'm just exaggerating it to demonstrate this. Okay, so this sag is the one that we are correcting for. Now you will apply this for every unsupported length of tape. So what do you mean by unsupported length of tape? Let's say if you're measuring 50 meters and then you measured it 2 times. The 30 meter length, and then this should be a little bit shorter. So bear with me here. Okay, and then you have your 20 meter measurement. Now you will apply the correction due to sag for these two instances right here, because you have two segments here that are unsupported, which caused the sag. Okay, so in practical applications, it is best to prevent this correction due to sag in the first place by supporting the tape at equal intervals if possible. But if it is not possible, then we have a formula right here that we can use to correct the measured line as much as possible. Then we have here tape not level and tape off line. Okay, let's start with tape off line here. If you have a line AB right here, and your tape in green right here is not in line with line AB, then you have to apply some corrections. So H is the length that you want to find, and then L right here is your measured tape length, and then D here is the deviation from the line. Okay, so we have a triangle right here. We have a right triangle, so we can use the Pythagorean theorem for that with L as our hypotenuse, and then manipulating the formula, we have H is equal to square root of L squared minus D squared. Now the same thing happens if you have a tape is not level right here. So this is the ideal horizontal distance that we want, H. And then same thing, we have a triangle right here, a right triangle. So we can compensate for that using the Pythagorean theorem, the same formula right here. But this is a different scenario. This is a vertical, and this one right here is horizontal. Okay, so that is it for this introduction. So I've shown to you the different types of errors and the different formulas that we can use to correct for the systematic errors. So in the next videos, we will discuss some problems and we will solve them using these formulas. Thank you for watching this video, and I hope you learned something new. See you in the next video.